All right, I want to say the fall of 2015, so about a year and a half ago. I picked this out of one of the engineering graphics books, and we went through the process, and I found out very quickly that I was getting frustrated with the cam action of this piece. The geometry didn't quite line up. So I want to revisit at least the portion. And we're going to do this out of the assembly with blocks. So picking my geometry, things that I'm interested in. I kind of have to go with some base geometry. And so the side frame, one of the side frames in profile will give me this basic slot geometry. And what happens is the air cylinder is mounted to this to the back plate, and it drives this pin up and down through this slot. And then we come over to the center block, and it's supposed to catch that center block and rotate into position and back out of position. So the geometry that I couldn't quite make line up was pretty much around the center block. So what I'm looking for is the pretty much our standard, the standard geometry that will make this swing that arc and drive that pin through this linear motion. All right, so to do that, I'm going to go into the assembly, and we're going to pick out some base geometry. Let's see if I can zoom, maybe. There we go. All right. So let's see. This is an inch. So we're just going to open up a. Oh, I did not create a template for my assembly, so we're just going to go back, pick up one of the other assembly templates. It is in inch, pounds, and seconds. And on the begin assembly, we haven't. We're not generating in geometry. We're doing this as a with the intent of eventually building something off those blocks, or building that top-down in context relations. So don't need to do anything with the beginning assembly, but we can go directly into the create layout. All right. So for my layout, we'll stay on the this front plane. And I'm not going to go to any extreme detail on the geometry, but we'll get it kind of started. So 1.375. Don't really have the units that I want. What do we have for an overall? So 2 inches overall. Okay, that looks a little bit better. And I'm going to put in the geometry that well, at least makes sense. So let's go with I'm in a layout, a 3D sketch, so I don't get access to the slot. So in this case, I'm going to go ahead and generate a center line. We'll go with a standard line. Do the continuous arc. Back to a line. Back to my start point.
Why not a slot?
Because in a 3D sketch, slot, polygon, ellipse, text are not available. Okay, so since you don't get them, then you get to draw them. All right, then I'm going to attach my center line to the center points, maybe. Make sure that we have tangencies all the way around. So tangent, tangent, and those go to the blue points. What do we have? A radius of 0.156. So it's a 5/16 slot. And what do we have for a length? 1.25. And we're going to need to pull that out a little bit. Not exactly centered. Okay, so those go to the bottom. And this was one of those, and let me fly this back in so we can take a look at it. Oops, missed it. All right, so kind of one of the first clues is this 0.125 going to the center of the arc, but then there's another 0.125 that looks like it's coming off that edge to the end of the arc. So one of those has got to be our preference, and it makes me think that that really should have been 0.25 because we're going to get awfully thin to the wall with the other geometry in place. So a lot of deciphering going on in this, and then some more 0.125s that don't quite work out. So maybe an inch or inch, well, that wouldn't be, maybe a 0.625. So we had to make some decisions on those numbers. So this one is a good, really is a good one for the whole design for manufacture, going through the process, determining what the actual dimensions should be. So just on looks, 0.25 looks pretty good. Let's jump over to to the center line. That looks like 0.75. Okay, so we're getting close. Let's see, why isn't that going fully defined? So that's always interesting when nothing moves and we're not fully defined. So I've got endpoints, and I'm reasonably happy that that is actually defined, since I've got the endpoint showing up in black. The radius of 0.16, still not moving. So tangent, tangent, horizontal, tangent, tangent, horizontal. That shouldn't be doing anything weird.
Is it because it's in a layout?
Probably more so it's in the 3D sketch and it's just not solved or hasn't fully solved yet.
I had this problem with 3D sketch the other day too, drawing out a polygon.
Yeah, 3D sketches are kind of notorious that you know, in this case I'm not going to fight it. I've kind of confirmed that all of these dimensions and relations, it's not going to move on me. I'm going to go on and then either in the process, well, let's get out of the sketch. No, it's all on plane. Or when we get out of the sketch, it may go fully defined on its own. If it doesn't, that's not the intent or my end result that I'm looking for. So I'll just kind of work through it and see what happens. All right, so we have a 0.158, which is kind of a weird number. Unless they're rounding a 4 millimeter, which is very possible. So on this side we have a couple of those. So I'm going to do a Control C and a Control V and a Control V. All right, and then one more circle. And I don't know that I need all of these, except the dimensions are kind of baselined off of each other. So I'd rather have them in there and not need them. So these are going to be set horizontal. Let's see. Go ahead and escape out. Make sure that back to my geometry, 0.375 from the base. And I'm not sure if that is from the base with the lip, or you got to assume it's the bottom of the part. And then this one was 0.5. So since that geometry gets kind of close, let's see what that one looks like as 0.125. And then 0.75 the center, and 0.25 either side. And, oh, I missed the dimensions, so.
So because we copied those, are they locked? I mean, are they?
No, they're not automatically set to equal, because that's why they're still showing up in in blue. So just because you copy, they'll be the same size because of the copy, but the relation doesn't come with it. So we're going to do the select, control select through the 3 and set them to equal. Then we'll be fully defined.
Or still blue.
Well, you're in a 3D sketch, so that's not surprising. What you can do is if you highlight and it shows up with equal radius, then go ahead. So yeah, I think we're far enough along. All right, for the geometry that I'm concerned with. All right, so making this into a block. On the layout towards the side. All right, so kind of by way of explanation, the reason that we're going to make these into blocks is that they can exist in this 3D sketch as separate entities, but we can relate them to each other. So when I'm looking in this case for that cam motion and where this line actually needs to be, where that geometry should end up, I can relate the tangencies. I can relate some of the belt and chain and gear mates in the within the blocks, but not have to have separate sketches. All right, so kind of see where that that lands us here. All right, so picking everything that I've sketched, I'm going to make the block. All right, and all of this was the frame. We need an insertion point if I bring in another one. So I'm going to go ahead and place it at the origin. Oh, okay, there it is. So this little arrow that pops up, that is going to be the insertion point. I'm going to put it on the bottom right corner. So kind of jumped out there. It put it at the center of the hole, kind of my first entity, and we're just going to drag it to that new location. Once I hit OK, and let's see, go ahead and shouldn't have to rebuild.
Once you hit the insert the block.
Okay, so you insert the block. You're under the layout tab in the top, and over on the right is to make it a block. Okay. All right. So since this is a block, it's also attached. And let's see, we are. Don't really need to save it. It did show up as a block, so that's okay. I think if I needed to move it, I would just need to. Well, let's double check. I'll get rid of the coincident. Oh, that was why that one wasn't. All right, but it does move like it's supposed to, so that's good. Let's see. Did I pull any? Well, we had a bunch of coincidences there. On plane, which I'm okay with the on plane. All right, so our first error in 3D Sketch. So let's go back and edit the block. Oh, whoops. Well, let me undo because I don't think I thought I had everything selected, but apparently I did not. So let's see. Well, that may have been a small tactical error there. So if that moves around, because when I'm editing the block, I don't. All right, so everything's still showing up in black except for when I edit the block, the center line. So that was kind of interesting. I thought I had more selected. I'm going to go ahead and hit the rebuild, which is going to kick me out of the sketch. The mates are showing up as layout items on plane. May have to. Or explode the block. Yeah, it doesn't look like we have much options there. Okay.
Explode the block?
Yeah.
Does that take you back to your original sketch?
Yeah, pretty much. Now the problem was now the block would be okay if you added the block and all this geometry showed up in it. Only my center line showed up. That was my concern. Everything else great, and we were looking at that that transition back and forth. All right, so they're moving together, so everything's pretty well defined. So let's try again. Make sure everything's selected. Make block. Ah, that was what I missed. Block entities, line 10. That is not very much in the way of selection. Right? So only blocks made from one line or arc can be made in a 3D sketch without sketching on a plane first. Well, we did. Okay, so what it's telling me is that I need to go back into the front plane, grab that line, grab that center line, and make sure that it is on plane in the current selected plane. It is that picky. All right. This is when this is out of this plane or not shown as on plane, then it is existing in the 3D sketch where everything else was picked up on the front plane. All right, so let's try that again. Ah, everything showed up that time. And we'll go ahead and make block. Nope. See what error it gives me this time. So it's interesting, I'm still ending up with all of those. Well, those are coincidences back to the geometry. All right, so front plane.
What does the block do for us?
Well, if we can ever get it to work, the block is going to allow this to be a grouped or an individual entity. So when we build the next entity and relate them, we can see how they interact together. And then we can eventually make parts from the blocks. And since it's not going too well, and in my previous experience, I'm already getting frustrated. So let's see what it's picking up here. Okay, so we did the block. Now that time it grabbed everything. Let's double check the insertion point. And it doesn't really matter at that stage, so we'll go ahead and accept it. Everything turned gray. Whew. I was getting a little worried there. All right, so the purpose is now this is an entity as a group or as a the single item, and I believe that we can. I would say I thought we could hide it, but maybe not. All right, so let's try for the pin anyway as an illustration. Going through the center geometry, this item 7 is going to move back and forth along the pin and engage in the center block. So let's find item 7. It has the radius of 0.313, which is interesting because we put this at 1.156. So already there's an interference tolerance of about 1,000. All right, so these are the things that we're going through and for better or worse, nitpicking this this item that we're going to have to resolve. All right, so on the front plane, I'm going to draw the circle 0.313 as they did. I'm not sure exactly what I'm going to have for a slot relation. No, not really. So we'll make it coincident. Oh, the block's moving, so I didn't quite get that to an insertion point. So let's make that corner coincident because I can't have it moving around. Can't have it rotating either. So let's try a horizontal. So we got a few relations to it. Okay, so my block is now stable. And so I'm able to move this back and forth. And with its diameter, I don't know that I need to make this a block just yet. At least I hope I don't need to make it a block at this point. All right, so that gives us the rotation. All right, so the geometry that I'm interested here then is pretty much where can I look at this actual arc. So I think this was supposed to be relief for the bottom side of that pin, and it engages and rotates this over. So let's start with where can I pick up that radius? So radius of 0.188. So there's plenty of clearance, and I think I'm going to draw this kind of off to one side. So again, with just kind of the rectangle. And we have the 0.688. So I'm going to start with that as the location. Overall, to the center point, that looks like 9/16. Okay, that got kind of fuzzed out. I may have to go back to the original and pick it up. So we have some 0.625 and 0.625, so that should give me 1 1/4. Maybe. Sort of looks like it on the height. So 0.65 to 625 to the edge, and then 0.625 to the top. So I'm double check my number here to that, and then from there to there. All right, so I'm going with it. Let's go ahead and put in a location, or the circle location. So 0.25 up and 0.375 in. All right, and that's off the leading edge. So we still have some geometry that we're going to have to work from here. We've drawn this on the front plane still, and the circle was on the front plane. So as long as we don't pick it for our make block, we should be okay. All right. So for the arc then, well, let's go ahead and this is going to come down at some angle. This is going to be parallel. And then I'll do the continuous to generate the tangent arc. It did go to tangency there, so that's okay. We had a radius of 0.188. What else? Okay, so back to the circle. I think that's a 0.562. And then it gets kind of weird from there. Let's see, 187 from the center. No, that's to the edge. And let's go, well, let's try the 0.562 from that side. Nope, that made that go away. So that extra geometry out there is something that we still need. So did that get really small or did it invert? Okay, it got really small.
Is there an angle in there? Oh, like 1.3 from the top? Is that?
Yeah, if the other numbers are holding. So let's go with it. 0.13 sounds good. All right, but that did end up inverting me on that geometry. So I'm going to take that off of coincident and see if we can move it back up a little ways. And it's showing a little bit of an edge here, and we'll kind of fake that one in. So that did not go horizontal. So 0.187 to the outside, 0.187 tall. And where is it as far as location? Well, that's from the center line of the slot. And 0.1. It's not working very fast to get me to be fully defined, is it? Yeah, this is a busy part, so I can understand where the issue is. If we were designing this from, oh, there it is, 45 on the angle, kind of hanging out in space, so it doesn't like that one. So what did we pick up that we got parallel? Nope, still wants to be a driven dimension. So that one comes up 58, but then they show 45 at the outside. So let's fly it in, take a look. So it looks like 45 coming back to this edge. Yeah, that's another one of those. Not sure. All right, our end goal though is to resolve this geometry. So let's go ahead and put it into the block. Let's go ahead and trim out an entity or two. All right, so as long as those will stay reasonably in relation to each other, pretty much it's this this circle going to be at the center of this one, related to this, that's going to determine how we're going to move. That's my story, and I'm sticking to it. So if we pick all of that and make a block, and we have all the line geometry, we go to insertion point. Insertion point should be at the center of the circle if we need another one. All right, and then let's see, the other thing that I sort of remember is that the drawing is this way, but then the orientation is this way. So it catches and it pulls it back. So that means that this needs to be able to rotate about that center point. All right, so that is actually doing what it's supposed to do. So the question is, can this and let me zoom up a little bit, and the answer is no, it cannot. Can we stay on this line and move this through the arc tangent? All right, so as we move through our dimension, we can contact here, but when I come back, I'm in kind of a bind there.
Oh. If you hadn't set that 45 degrees, would that solve that?
Well, the dimensions at this point, the dimensions are driving. So the 58 degrees, that's something that needs to be resolved. Yes, is the 45 degrees has precedence over the 130. So the number that I'm not sure about was the center point distance from here to here.
Oh, that's cool. So you can make a tangent and drag it around.
Exactly, is we can go ahead and set those relations. All right, and this is only going to move, and actually that's moving much better than I expected it to. So the problem becomes the contact points that were tangent on that one segment, but we're not really tangent through the entire path. All right, so when it's pushing, we're on this side, but when it's pulling, it really needs to be on this side. So let's put another circle and see what happens. Okay, so those are going to be equal. And then should be able to make those two tangent. So it finds its location. But they never quite coincide. So as long as we have that 1/16 of an inch, it looks like it'll travel through the arc. And at the end result, it's going to be the air cylinder, the stroke of the air cylinder that determines, well, the stroke of the air cylinder and the depth of the slot that determines how far that can travel. Okay, so the block tells us that should work, even with all of that clearance and all of those steps.
You put the other circle in.
Just to see where it would contact along, the second circle is to contact along this back side. Because when you're pushing forward, the air cylinder is on this side. When we're pushing forward, it's going to contact like we have it. But when it pulls back, it's going to take up that 1/16 of an inch, and it's going to contact along that point. So as it rotates through that, I guess the question is, when it, we're not really in rotation at this level. When it pulls it back and hits that point, are we far enough on the tangency that it will push it over, pick up the tangency, and pull it back to the retraction point? So now I don't know what my issue was. So let's go ahead and close the layout, and we'll save that as an assembly. All right, so this was the landing gear retract assembly layout, and we'll go ahead and save. All right, so somewhere on my external drive, hopefully, not too buried too far deep, those were the drawings. That was what I needed. Uh-oh.
You could have this as a separate document just to just
Figure it out.
Proof of concept.
Right.
Thing. Cool.
Okay, so we made the drawings. Now I can't find my, oops. All right, we created the layout. Oh, okay, so, well, 15, all right, so that's the completed 2015 assembly. And we'll go ahead and rebuild. So let's see if we can determine what the issue was. So either I missed the arc geometry. We got it's 0.13. We got the other geometry in. So that almost looks like the slot geometry is too high. So I may have taken it off of this edge instead of this edge, which that would be an easy mistake based on the how well the isometrics are drawn and dimensioned. Going through that process on the push. All right, so the slot mate will go side to side. And if we were to set up for the tangency or for a path, but the problem with the path is this won't contact through the bottom of the arc. So out of my mate selections, let's go look at the advanced. So even though I have a profile center symmetric, I don't think we wouldn't be able to do the slot. I could possibly set the center line, which would be the tolerance zone again, and have it be able to move up and down on the center line. So there's some weird mates that that come into play also. And then on the mechanical mates, nothing really coming into that group. All right, so what I've done is gone back and pretty much that this angle, since this angle raised up, some of the other geometry, some of the other dimensions don't quite play out. I've kind of proven that operator error. I made a mistake on the center line, and if we were to go back through on this geometry, could probably make that correction. But we want to build this out a little bit, and then looking at this, one of the things that jumps out is as much load or as much force. We don't really know what the cylinder is actuating. The gears are out here somewhere. That whatever is rotating, that this is probably going to be a fairly significant force. So if I was going to do FEA on something, this would be it. This is a major stress riser. Putting a radius, thickening up that that cross section is going to go a long ways for building in additional strength. Okay, so when we jump over into the FEA, this is a prime candidate. All right, so at this stage, I have a couple of options before I go in and start butchering this this assembly, this sub-assembly. Because I know I'm going to need to make corrections that I'm going to have to go back and decipher what I did a year and a half ago. This would be a good place to pack and go. And what pack and go says, I want a snapshot as it is right now. All right, before I do anything else, and under File, Pack and Go, this is going to pull in toolbox components. Oh, excuse me. And include the toolbox components. If we select, we haven't generated any simulation results, we'll go ahead and throw the drawing in there. There's no custom decals. And so one of the issues with Pack and Go is at the sub-assembly level, this is going to be fine. It's going to gather these up and put them in one zip file in one folder. What it's not going to do well is if I have a top level assembly with 3 sub-assemblies with 6 sub-sub-assemblies and another 4 or 5 sub-sub-sub-assemblies, it's going to take all of those files and dump them into one folder. We lose that structure going into Pack and Go, and that is a major issue on more complex assemblies. So from the strategy standpoint, this will gather up, like I said, the drawings, it'll gather up the toolbox components, and it will make that instant snapshot, but really at that sub-assembly level before I go in and make an issue. So the flattened to single folder, when I've unchecked that, it still kind of gathers everything up and doesn't quite keep the same structure. So we'll have to try that, but again, it's kind of one of those warning things of utilize it to make your backup, but be aware that the flattened to single folder still has issues with that geometry, or with all of those files. So that put that in the same file location. What I would probably recommend as a strategy then, graphics card, fun. As a strategy, so there's my Pack and Go that was generated. Okay, I guess I'd go find it again.
Have you ever had to use recover an assembly from Pack and Go? Or?
Yeah, we've we're kind of going along, painting ourselves into corners on a regular basis, do those snapshots along the way and then decide to go back 1 or 2 steps. So really the issue is, do I go pack and go, which gathers up all of the fasteners? So I think pack and go is probably more functional to send this to a customer, to send it out for, to make sure all of the hardware, all of the network items, anything that's strewn all over the computer gets to one place. For my actual backup, I would probably still just go with, if you have the 7-zip, the WinRAR, the WinZip, whatever, or just do the standard send to, a compressed zip folder. That is going to take that snapshot of the assembly, and we put in a date stamp. That is probably my better bet. All right, I still will have the same folder structure. I will still, any sub-assemblies, I don't have to worry about losing that internal structure within the Windows file folder structure.
Oh,
Just by compressing it, not even worrying about letting SolidWorks do it.
So just grab the assembly.
I went to the top level folder, and at the top level folder, wherever it went again, and just right click on that folder, grab everything in it. So if this is one of those really complicated structures, I still have my snapshot. Okay. So at this point, I don't really want to delve in this until I have a chance to digest. If you want to see the process of maybe a Saturday morning, go through and start beating on this thing. Since we're talking more about the blocks and verifying, not verifying, or proving, disproving, then the other thing that we can do is, out of the block, is we have make part from block. All right, so still not a strategy that I do. I can't say that I've done it more than as demos. All right, but if I go in, grab block 2.1, and we project or pick up the block. All right, if I project it, it's going to need to come off some distance. So for our step, that would be about right. We have some distance. Oops, close the wrong one.
Where do you input the distance?
Okay, so I have to tell it either on block, which would, I believe, is the current plane, or in the projection. All right, so it makes the sketch of the block. And there is block 2-1 as a inserted item. And it really didn't move it where I thought it would on the projection. So let's go ahead and open up the part. And no. So that's what we want to see is, go ahead and extrude it. 0.38, I believe, was the width. No. That's what I get for guessing. 0.125. So that looks awful thick. Okay, so rebuild, save, and close. All right, so this part is in. It's in relation to that block. And I should be able to grab and treat this just like, let's see, this was the left one, so it should really go that way. So if this is my midplane, my midplane geometry, let's see, what are we going to have for the width? About the same width as the back plate, which is 2 inches. So for the mate, it is picked up as a layout, the part projected. So I believe if it was on block, it would be locked into that plane, but we'll have to try that on the next one. All right, so front plane, Back over, we'll go ahead and set the mate distance. Still thinking about it, getting ready to crash, doing something. All right, let's try to mate. Set the distance 1 inch. Flip the dimension. Okay, get it back to that side, and that puts it in location. So the other issue is that the right frame carries the bearing. It doesn't have these two holes. All right, so that would be something that either as the second block we'd go back and do some direct editing. And are those, well, I'm kind of backwards from the, no, I'm okay with the left, I'm not okay with the right. I don't know. All right, so let's see, we have the block. I really want to make that a left or right. Well, that block was pretty much consumed. As part of the, no, I went to the sketch. Yeah, block 2-1 was consumed into the part. So let's see, coming up with a strategy because I still need a right side. Let's see if we save the block, same location. I just want to see if I can reuse it. Okay. So it didn't quite do what I expected it to. So insert, let's see, back into the layout, insert block. Well, it's still asking for the sketch, so we got to go back to the layout. Insert block. We had block 3, block 1, or I can browse. All right, so that was the only one that I externalized. There's the frame, solid block. Go ahead and place it. Okay, so frame 1 goes into the mix. I highlight it. Now we're back to make part from block, project. All right, so I really should edit the block and remove those 2 circles. And then there is the separate. So if I got the naming organized a little bit better, that would probably help. And that's also going to be 125. All right, so if we edit sketch, then I'll leave those. Well, did the whole thing. That was nice of it. And edit the block. There we go. Switch that over to construction geometry if it'll let it. Show the problem. Sketch has both open and closed contours. So it got rid of that as the center line. Okay. And we're backing out. And we still have the other geometry. Let's see, 0.25, so it's the same size. And close that back. And face to front plane, distance 1 point, and accept. Okay, so the issue should be, or is, that the slide pin at 0.313, we didn't create a block with those. So this one was internal, this one was externalized so that I could create the separate. And basically, yeah, it's allowing me to duplicate it, so that's okay. Still need to put the wings on and the other cuts and geometry into the mix. So let's try for block 3, and right click, go make part from block, and let's just leave it as on block for this one. No, it still didn't define it, and we got position. So where this one put me in position, this one gave me the layout and the distance, but it's still free to rotate. So we either need a parallel or a coincident. Okay, and then we'll see what the block looks like. So let's just edit that one in context, edit part. And then sketch 1.
What's the pivot on that, the insertion point for the block?
Now there's a, actually I think it's pivoting on the mate.
Oh.
So if we go to 2-inch, then that should be the interference. So there is if we're up against the base, that's going to contact. Oh, and it's still dragging the block and the pins. Pretty cool. So I still don't know that this is the best example. I still don't have my head completely wrapped around it, as far as what I would like this to be able to do. One of the things as far as the mates, though, if we were to go in and set a limit angle. Okay, so I get the mate in there. I'll just go back and edit it. Go to the advanced mates. It's still an angle, and we want to go from maximum of 90 degrees to 0 degrees. Then, well, okay, 0 to minus 90 degrees. That's always the fun part. Let's see if we flip the dimension. Let it go the right way. Jump the tangencies. So when I moved the wrong way, it put the circles to the outside of the tangency. So not quite the result that I was looking for, but we're probably not too far. Let's get back into the layout. So that one went fully defined. So let's get rid of its tangency and bring it back in. Don't want the midpoint. Hopefully that's the block. Yep, did it again. So let's see, you're going to have to get rid of that one's tangency. And set the tangency. All right. So we can still see the movement. We can see the stack of the tolerances and watch it rotate. Look for interferences and that kind of geometry. So I don't know that I would build the assembly just strictly on this geometry. I don't know that the blocks are that user-friendly. On the other hand, I haven't used them enough to say that I can discount this or eliminate it as a strategy. In our what-if scenario, I have something that's complicated like the cam movement. Then this is going to be, let's simplify it down to just the geometry that I need and verify that the positions, that the things are going to work okay. But then be prepared to refine it, go through the process. And I would still probably prefer to have the individual components. I don't know, I'm kind of torn. And I kind of look at it from the standpoint of I send this to a customer, I send this to my detailer, we go to design review. are they going to freak out when they see all the blocks and what the heck is that doing, and that kind of stuff. So at this point, with the other thing I just noticed is with the brackets, this is all internal. There are no externalized parts at this point. So we can rename and then save part and external file to get them extracted, to get them out, and be able to do the rest of the geometry. So be a fun experiment.
How about interference checks or clearance checks? Is that
not really at this point? I would say in the other model. Let's go ahead and we'll save that one.
will blocks let you do that though?
More so, just like what we were looking. The interference check is more just in that 2D space or in those two axes that we're moving in. If you want to do full up interference, then we're going to need to look at the geometry. So I think one of the issues was this radius was larger and it contacted the endpoint, and we're not quite moving through all of our same motion. Let's see, that was at a 90 degree. So to actually evaluate this for our let's see, for interference, interference detection and clearance detection, those are specific. Looking just between the components and calculating how much clearance is, how much is in there. For actual collision, the best collision detection is still going to be under move component. That when I go to move component and we go to collision detection, go to these components, I want to see, is there collision between this and this. All right, when I resume the drag and it rotates, it will stop at its limits, but it will also make the noise and highlight in blue where there's contact. So let me check real quick and we'll verify. I want to say that radius originally started off at 0.5, so yeah, we know. So if I rebuild there, and we'll start it off out of oh no, it was 0.25. No. Okay, let's look at it at 0.5 and then we'll back it down to 0.25. All right, so move component, collision detection, these components, that one's highlighted. We want to see where it's going to contact. So at that point it highlights and it shows you that it's in collision. So that's kind of a real-time dynamic detection. The other interference and clearance detection is just going to be straight calculations. What are the mins and maxes of your components? Okay, so if I go back and we pick that one up again and I go to 0.25 and rebuild, then one more check says collision detection, these components, let's go from there to there, and I'm still hitting. Now if that's acting as a stop, that may be okay. At that point, that may be the stop from keeping it going too far.
Unless it jams in there.
But yeah, unless we gall it and actually manage to lock it in place. All right, so another location that we would be interested in, the 0.25. Well, actually, that's a little bit past center, so it kind of depends on what this can do, pulling back. Is what is the load on the gears? What is the actual operation? And so that was one of the things that was in the mix. Is, do we have a bearing retainer? Oh no, this was the stationary gear, and then the other gear rotated about the stationary gear. So maybe we can take this. I'll take a pass and make the corrections on the slot and verify the geometry. And then we'll go out to a website like Stock Drive Products, SDP, SI, and pull in some bevel gears and see what we can do with their geometry. All right, we're gonna call that good.